When it comes to data, the faster you can turn this into this, the faster you can understand and use it all to make your business run better.
Let's say your entire organization wants to set up Power BI dashboards that use consistent colors and fonts. Report themes allow us to scale formatting across many dashboards. Report themes may not work with custom visuals, however, and you can override the report theme by manually selecting the colors if you would like. When you publish the file to a Power BI service, the uploaded dashboards will retain the formatting options imported from the report theme. We are going to use a pretty simple report theme example in this video, but for those of you that are interested in learning more about detailed report themes and updating it to fit your own organization's themes and colors, check out the fantastic Microsoft documentation on this topic on their website we see here on the screen. We set up our report theme in a JSON file, which is a data structure that is short for JavaScript Object Notation, where we pass the formatting and color information into Power BI in pairs. You do not have to know much about JSON files to set up this report, other than how to update and change the formatting we pass through it. The name field is the only required parameter in the JSON report theme. The rest of the parameters in report themes are optional. Whatever parameters we do not set up in this report theme, Power BI will revert to the default formatting for. The Data Colors section allows us to import an unlimited number of colors into our Power BI report. Since we use the US Census and IRS data for this project, I downloaded their logos and matched them up and found complementary colors to go along with the existing colors in the logos. In your report theme, we need to make sure to put the colors into the JSON file as hex values, which means they start with a hash symbol and they're followed by 6 alphanumeric characters that denote the color value. I added a spectrum of blue colors to this JSON file, along with gray colors and orange colors to go with the scheme as well. This will accommodate some of the colorblind viewers and users of these Power BI reports. We can also set up a color for the maximum, center, and minimum, which enable us to format the coloring for our heat maps that use these color scales. Notice that all these hex values and the parameters are in quotation marks. Power BI will not import your report theme at all if you do not set it up this way. Feel free to save my JSON file seen here and also in the exercise files and update it with your own color and formatting information. We can import this report theme into Power BI by selecting Switch Theme at the top. We can choose from a number of pre-existing report themes, or we can even add a colorblind scheme. However, we want to import the theme we just set up. Select the Import Theme option. Now we point to the JSON file that we saved in the exercise folders and hit OK. After hitting Import, we receive a message that the theme was successfully imported into Power BI. If you get an error message, I would suggest, from personal experience in testing this out, that first make sure that you've saved your file as a JSON format extension with JSON at the end, and also make sure that you saved your color values as properly formatted hex values. After making these updates, you can then try to import the updated report theme again to make sure it works. In Power BI, tables are visuals themselves. I often begin data analysis by first creating tables to make sure the numbers and calculations work as expected before changing the tables into more visually appealing charts. I think tables provide great insight for both high-level summaries and also for detailed views that drill down into the most granular of data. Let's first create a tabular pivot table by selecting the table from the standard visuals list. We now see an empty visual that we can populate with our fields. Start by adding the state field from the year 2 state FIPS, the main key, by dragging the state field to the values area. To increase the size of the values in this table, we go to the Format options represented with this paint roller icon in the Visualizations pane. In the Grid options, we select to increase the size of the font so that it makes it easier to see. We can then increase the size of the chart by clicking on the edge of it and moving it to increase the size. We can widen the column widths to make it easier to see DC, for example, by hovering over the column border, and when this arrow appears, drag it to the desired width. We can also wrap the column labels by selecting the column headers and selecting Word Wrap. And we can do the same for the values if we drag the column width to a much smaller size. Let's keep this as a wider column so we don't see this variation in the row height. We then add the population field. We go to the US population data and drag the population field. We can either drag it to the table or we can drag it to the values list underneath the fields. Aggregation options for populations, which is a value, include the options we see by clicking on the down arrow. We see average, minimum, count, median. We can also select to not summarize it. We see sum selected. We click out of it to leave the sum aggregation the same way. We see some populations do not have row labels, and this occurs because some GeoIDs in more rural areas like Alaska and Wyoming changed over the 50-year period and do not match up with the current GeoID keys. It is also a small number in our U.S. population analysis that will not have a significant impact in our analysis later. Notice that we also find it difficult to read the numbers in this chart because we cannot easily denote or immediately see how big the numbers are because they are quite large. Select the population field, go to the modeling options, and select the comma as the separator for the numbers. This makes it easier to read the population totals in the chart. The pivot coordinates in the table visual are the row dimensions that we aggregated our measured values like population totals by. We can change the order of the fields or columns in this chart by simply dragging them to a different position in this values list. I prefer to see population to the right of the state name because that is how we typically see it in more standardized reports. So we click and drag it back to the same position. We can add the date field to the table visual by going to the years table and selecting the year, which is a date field. We add the date field to the table visual by selecting it and dragging it over between the state and the population values. We notice that the date field adds 4 date components. And since we only need the year, we can remove the quarter, month, and day by simply clicking on the X next to the date component name. Notice how the table now has a lot more rows because we now have rows for all combinations of 50 states plus Washington, D.C., and we multiply that by almost 50 years of data points, which equals about 2,500 pivot coordinates to evaluate the aggregated population numbers by. If we want to compare the population for a single state to the other state populations that year, we find the tabular pivot table we see on the screen makes it difficult to see these trends because we see almost 50 years of rows for each state before we get to the next state on the list. A matrix visual adds column labels to a table visual, which makes it easier to read the summarized data. To change the table visual into a matrix visual, we select it so that it's highlighted. Then we choose the matrix visual right next to the table visual. We want to see the state in the rows, the year in the columns, and the population in the values field. The population numbers are now aggregated by both the row pivot coordinates and the column pivot coordinates. We can rank the table populations instead of using the alphabetical order of the states by selecting the ellipsis in the upper right-hand corner of the chart, and we choose sort by population instead of state. Now we see that this sorts the numbers in descending order. Populations are snapshots in time measurements, so it does not make sense to add them all together as we see in the column totals. To remove this total, go to the formatting options, select the subtotals menu, and turn off the button for the column subtotals. Let's leave the row subtotals in the chart as a reference point for the U.S. population numbers. If we have years and states with empty populations, we can make sure these are included by selecting the field options and clicking on one of the fields, state for example, and selecting Show Items with No Data. This makes sure that we see the fields in the chart even if they do not have related values. I would like to change the color of the blue line that separates the table rows, columns, and values to make it a bit easier to read and not stand out necessarily as much. Go to the formatting options. Then in the grid menu, we can select to change the outline color. This outline color actually comes through the report theme we already imported into the Power BI file. We select a light gray to use for this, and we see enough of a line to delineate between the components of the chart without drawing too much attention to the line itself. We add a title visual to this matrix by going into the title section of the formatting options, turning the radio button to on, and we can now enter our title text in the empty field. We're going to call this U.S. population numbers by state and year. And we see it's automatically updated in the top of the chart. We can select the alignment, and we can also increase the text size to make it a bit easier to read. Let's make this just a little bit bigger than the 18-point text we see in the chart itself. And we can change the color of the font as well. Black works. We can also select it to a darker gray so it doesn't necessarily stand out as much. In Power BI, in the GeoID lookup table, we see that the geographical hierarchies exist where each county rolls up into a state geography that includes the rest of the counties within the state. The state totals we see in the matrix visual come from adding together the total populations for all the counties in the state for each given year. Select the county field in the GeoID table, then go to the modeling menu, and in the data category menu, we select county as the data type. Notice that we now see a globe icon next to the field name, which indicates it is a geographical field. We can do the same for the state field in the GeoID table. To create the geographical hierarchy, we take the county field and drag it on top of the state field. This creates a new hierarchy comprised of these two fields. If we double-click on the name, we can rename it U.S. Geographical Hierarchy and hit Enter to save the name. We now add the geographical hierarchy to the matrix visual. Drag the entire hierarchy to the rows, and then we remove the state field that was already there. At first, it does not appear that the hierarchy is properly showing up, but this occurs because we only see the first layer of the hierarchy, which is the state level. If we want to see the county totals, we can click on the icon at the top with the two down arrows. We see the county populations by year, but notice that we now do not see the state information. We use the symbol with the single up arrow to get back to the state level. Now, if we want to see both the state and county levels for a single state, we have a few options for navigating the table. We can select the single down arrow. We see it's now highlighted, which indicates the drill down functionality is on. Now we drill into the state of California by clicking on the name. We now see the state of California name at the top, followed by the populations within the state of California and organized by their population totals. However, if we scroll down, we only see the county populations for the state of California. To get back to the original level, we click on the drill up symbol, and we can select to drill down into another state. However, if we want to select to see the state population totals, followed by their counties, followed by another state population and their counties, we can use this symbol at the top with the two diverging arrows to see both levels at the same time. We select this option, and we now see a long list of county populations by state for all the U.S. states. In Power BI, let's remove the blank row dimensions from the matrix visual. These are the population GeoIDs that no longer exist in current U.S. geographical data. These are for smaller states, such as Alaska and Wyoming, and are not going to be significant in the entire U.S. population analysis as a whole. We can filter them out directly in the visual. We highlight the matrix table, and we see that the filter options pane next to it shows that the filters only apply to the visual, and they also are default selected to all. We can select the state field and select the all function and then remove the blank from the list. Notice that it automatically applies to the visual. We can do the same for the county dimension just to be sure. Click to expand it, and now I'm going to select the advanced filtering because populations is a longer list, and we can directly select to only show the county names that are not blank. We select is not blank and apply the filter and collapse the menu option. Let's say we want to see the most recent population in the matrix visual. Let's first make a copy of the visual by selecting it, hitting Control Copy, and we can drag the end of the visual, fix up less space, and paste it somewhere else on the screen. We then go to the year filter option, and we select the basic options because we want to see a list of just all the years. Now, the most recent year is 2018, so we can select this. And this automatically applies to the entire visual we see here directly next to the filter pane. Now, let's say we want to filter this entire visual. We're going to go back up a layer so it makes it easier to see. We can add a filter to only show the top 5 US population states in the same filter pane. We can go to the State menu and we select Top N. We enter 5 in the top N. You can choose either the top or bottom items. And then here in the by value, we want to drag the population field directly into the filter. We hit apply. Now we see the table matrix filters down not only to the 2018 most recent population data, but also only shows the state populations for the top 5 most populous states. Another option for filtering is with specific date filtering. To test this out, we are going to just create a table visual with the date field. And we can drag out the year just to test how this works. Now we choose to use the actual date, which is the year, instead of the date hierarchy. And this is key because the filter options will depend on seeing the continuous date range rather than the date hierarchy components. Now we go into the filter options specifically for this visual, and we select the relative date filtering. We can select to see, let's say, the last 10 years. And we apply the filter. And we can also set this up to include the last 10 calendar years. And we again apply the filter. And this may make a difference depending on how you want to see the range of dates, but just keep in mind that there's 2 components to use there. Filters do not even have to be in the visual to necessarily apply them. We can add the filters to the visual filtering and also the page filtering and for all the pages or tabs of the dashboard. Let's test out how the page filtering works by taking the state of California and dragging it in the filters on all report pages option at the bottom, which would apply this filter to all the dashboard tabs within this Power BI file. In Power BI, we can group together values in a field as a list to easily include or exclude certain values in the field in our analysis. Let's start by removing the dates visual entirely because we don't need it anymore. And we can remove the California filter on the page. And I'm going to just remove this entire visual, and I'm also going to just expand this out so we can see it again. And we see that the county is not blank, the state is not blank, which is exactly what we want to start out with. Now we set up a list for the US states with the highest populations, and we set this up as a include or exclude list. In the year 2 state fifths key, we're going to select the state and choose the new group. I'm going to call this group state population size. And we're going to use this as a list. Now, we select the top 5 most recent US populations states. We select California, and to hold down the control key will allow us to select more states from this list. So California and control, select Florida, New York, and Texas. And we then select the group button at the bottom. We rename this field Top 5 US States and hit enter. And we can Control All, select the rest of the states and group those together. And I'll call this other U.S. states. If you missed any states, say you're grouping together a number of different actual groups, you can simply unselect by hitting ungroup, and you can highlight and to deselect or select the members of the group you want to include or exclude from the list, which makes it a lot easier than starting the entire process over again. So we hit group again because we want to use all of these. We're going to call this other U.S. states. And we'll deselect the foreign one. Control, highlight, and then we select group again. I call this other U.S. states. Once you finish the process, we hit OK to save the grouping. And we notice that there is a new group added to this state FIPS key that shows the group icon next to it, which indicates that it's an example of grouping. And we can add this grouping to the chart. We can also use it as a filter. So drag it over to the filters pane and select the top 5 US states. Then we collapse this. We now see that the grouping has been used to include the top 5 US states. And if we wanted to exclude them, we could change the filtering option. And we could also use these as labels for the charts. There's a lot of options we can leverage with the group listing options. Creating bins puts ranges of values into segments to make it easier to analyze numerical value distributions by reducing the dimensions from which we're evaluating those totals. To create population bins in Power BI, we can select the population field and go to the ellipsis next to it and select the new group option. We select bin from the group type, and we want to create bins of 100,000 people because it's population. We rename this population range bins, and we hit OK. We now see a new field in the US population data table with the grouping icon next to it. Let's create a new visual to show how the bins work by opening up a new dashboard tab. We create a new table with the county. I'm going to use the area name, which is going to include the county and the state name. And we add the population to the table. And let's make this a bit bigger so we can read it. '18 font, and we're just going to leave the outline color because we're just testing this out. Now we also add the new population bin that we created to the visual. And we want to filter this by the most recent years. So we go to the year, and I'm going to add the year as a filter for the visual. Basic filtering, and choose 2018. Okay. So this shows the most recent population of each county with the state identification, and this shows how we put them in the appropriate population bins. We want to make sure that in the visual, the population bins are not summarized. We don't want to see them summed up in this example. Notice how the population bins show the numbers that go down to the nearest 100,000. So the populations we see at the top, for example, that are under 100,000, they are in the population bin that uses 0. And we go and look at some of these larger populations, it essentially steps down to the 100,000 benchmark below that number. We can also use the population bins to create and structure entire tables around. And what I mean by this is we use them as a dimension in our visuals. Let's create a new table visual, and we add the population range, and we want to show this as a dimension, so select Don't Summarize. We now see all the ranges as row dimensions in the table. Next, we can drag the GeoID to this table, and we're using the GeoID just to test out how this works. It's not necessarily something we would use in the analysis as a whole. And we want to count the unique GeoIDs. So count distinct, and we see how the distribution of populations looks among counties in terms of the counts and the population distribution among the larger versus smaller county populations. If we add the population to this table as well and select for only the most recent year, we see that a lot of the population does not live in the smaller counties. Instead, we see they live in some of the larger counties. This is not a course on DAX, but we will find that even knowing just a little bit of DAX is immensely helpful for Power BI dashboards. If you want to learn more about leveraging DAX, check out some of my other courses on Power BI in the library. On a high level, we can think of DAX measure formulas in two components. First, think about the filters we want to apply to the data tables. And second, think about the calculation you want to perform on this filtered data table. In Power BI, I try to keep my DAX measures in a separate table. We can select Enter Data at the top. I'm going to rename this Calculations and just load it. We're going to create a DAX expression using the data in the tables already listed in the fields. I'm going to expand the table so we can see the names of the fields. Then we go to the calculations data table we just added and select New Measure. We're going to first create a measure to show the most recent year. This most recent year. Last date, which will return the last date of the years in the table. I'm going to use the year for the population data in this case. And Power BI supports smart prompts, so you can just type it in and hit Tab to pick it up. And I'm going to use the date for this one. So I'm going to use the year and enter. And now we can remove column 1 because we already have another measure added to the table. So I'm going to drag this to the blank canvas and show it. This shows the most recent year. But the key thing that we need to recognize when we're looking at DAX measures is how the filter operates is based on the pivot coordinates. So I'm going to take the year and add the calculation to the year in the population data. And we see that because we have row coordinates for the dates for those years, that it instead references these dates instead of none of them, which is how we end up with the last date of the data here. So we can add another expression to this formula to override those filters. I'm going to use the all selected for this example, which is going to allow us to dynamically interact with this data and this calculation later. And it updates to show the most recent population year. We see that these table visuals use the pivot coordinates that work like filters that allow us to calculate the expression based on the labels and the values in those rows. Now we can use this expression to calculate the most recent population, which is what we've been trying to accomplish with some of the filtering. Call this new measure most recent population, and I'm going to set up the calculation expression. I see the expression comes first, the filter is the second piece. I'm going to first add in the filter, and I'm going to come back to the expression. We use the same formula we used for the most recent year, and all selected, and show the year. Type in the population to get us the population year, and close this expression off. Now go into the first part of the expression, and I want to sum up the population over 2018. Now I add the population to the expression, a comma to separate them. And I need to close this off with a comma as well. And I know that the most recent US population is 327 million. Let me make this table a bit larger so we can see the values in it. Make this 18. And now add the recent population to the table. And we see that we have the 327 million we were expecting to see. We can also set up an expression to return the first population, which we're going to use in other calculations in our visual dashboards later. I'm going to call this first year population, which is the 1970 population as a reference. And we set this up using the same structure we used for the most recent population. And instead of using last date, we use its sibling for the minimum date, which is the first date, and all selected. And again, refer to the year. Hit enter to save that. And we then add it to our table. And add some commas to make it easier to read. Okay. So I'm going to make this a bit smaller so we can see more of the information. Now I'm going to just move this table off to the side and shrink it. And you can use this as your own reference later. And I'm going to use the state FIPS this time. I'm going to use the state name. I'm going to create a new table to get the population numbers. So we select to convert it from a map into a table, and then add the most recent population. And what we see is that the numbers for the most recent population changed because we are using the states as the row pivot coordinates. So we need to override the states if we want to get the total US population, which we are going to use as a reference. So we can create a new measure, call this total most recent US population, and set this up to reference the most recent population. We can use the measure, more specifically the DAX measure. We already created it as the expression. And then I'm going to override the state's coordinates just using the function all. And state, we want to reference the year to state FIPS key. So we scroll down and hit tab to pick it up, hit enter, and I'm going to make this table a little bigger. Now we've created this expression. It's going to override the state labels as the coordinates. So we add the total most recent population to the table, and we see that it returns 327 million for all the rows in the table, which is what we expected to see. We can let Power BI write our DAX measures for us through the quick measure functionality. We are going to set up a quick measure calculation for the year-over-year percentage population growth. We're going to use the years field and the U.S. population data, specifically the population numbers. We go to the calculations table, and we click on the ellipsis and select New Measure. This opens up a new dialog box. From the calculation drop-down list, we select year-over-year change from the time intelligence section. We now see two areas to enter our fields to set up the calculation. We want to go to the field selection and use the U.S. population data and the population field as our base value. The base value is the field we want to aggregate, and in this case, this is the U.S. population numbers. Now we add the years field to the date, and we keep the periods as 1 because we want to calculate the percentage change in the population each year. So we're going to use 1 as the unit of measurement there. We hit OK. Now notice the calculation. Power BI added this to our calculations table as with the default name, population year-over-year percentage. We can see the DAX code that Power BI automatically set up. We can change the name of the calculation, or we can change the code itself. But I would recommend leaving the code as is, because if we change something, it may not work as we anticipated. We click on the expand arrow to get out of the calculation. Now we set up a new table to show that the quick measures work as we want them to. Let's add the year field to the dashboard. And I'm going to increase the size of this. Now this is set up using a date hierarchy. Let's set this up using the actual date, so December 31st of each one of these census years. We see the long date currently on the screen. Now we add the population year-over-year percentage change to the visual. We get an error message. If we click on the See Details hyperlink, it tells us that these time intelligence quick measures need to be grouped by Power BI provided date hierarchy. We can close out of this and change the year field back into the date hierarchy. And we see our quick measure calculation properly works. We can then remove the day, month, quarter, because we only want to see those year-over-year values. And we see change in U.S. population growth over 50 years.